So parabola extra problems. First one, the equation of common tangent to the curves y square equal to 4x and x square plus 32y equal to 0 is of the form x plus by plus c equal to 0. Find the value of modulus of sin inverse of sin 1 plus sin inverse of sin b plus sin inverse of sin c. Second, the parabola C1 y square equal to 4a into x minus a and C2 y square equal to minus 4a into x minus k intersect at two distinct points a and b. If the slope of the tangent at a on C1 is same as slope of normal at b on C2, then the value of k, first option 3a, second option 2a, third option a, and fourth option 0. So the equation of the tangent to the parabola y square equal to 4x is y equal to mx plus 1 by m, and it is also a tangent to the parabola x square plus 32y equal to 0. So replace y with directly mx plus 1 by m, and this will be a quadratic in x, discriminant equal to 0. Then we get the value of m as 1 by 2. So the equation of the common tangent is x minus 2y plus 4 equal to 0. So b is minus 2 and c equal to 4. Substitute in this and simplify. So the value will be 1. So the two parabolas C1 and C2 intersect at A and B. If I take the coordinates of A as P comma Q, then the coordinates of B can be taken as P comma minus Q. So slope of the tangent to the curve C1 at P comma Q is 2A upon Q, and slope of the tangent at B to the curve C2 is minus 2A upon Q, and slope of the tangent at A on C1 is same as slope of the normal at B. Then you'll get Q equal to 2A, and substitute P comma Q in the parabola and simplify. So we'll get K equal to 2A. Third problem. If the line y equal to x minus 1 bisects two chords of the parabola y square equal to 4bx, which are passing through the point b comma minus 2b, then length of latus rectum can be equal to first option 3, second option 5, third option 6, fourth option 8. So the line y equal to x minus 1 bisects the two chords of the parabola y square equal to 4bx. So these are the two chords which bisected by the line y equal to x minus 1. So if I take x equal to t, then y equal to t minus 1. So the midpoint of the chord can be taken as t comma t minus 1. So equation of the chord bisected at a point p is t equal to s1, and which is passing through the point b comma minus 2b. So when you substitute it, you'll get a quadratic in t because you are having two chords. So discriminant must be greater than 0. When you simplify, so b lie between 0 to 1. So length of latus rectum 4b will be less than 4. So that means the option will be 3. Next. Fourth problem. Let the lines L1 and L2 be normal to the parabola y square equal to 4x and tangent to the parabola x square equal to minus 12y, where L1 and L2 are not x-axis. Find the absolute value of difference of slopes L1 and L2. First option 3, second option 2, third option 1, and fourth option 1 by 2. Fifth problem. If the equation of tangent at P3, 4 on the parabola whose axis is x-axis is 3x minus 4y plus 7 equals 0, then find the distance of the tangent from the focus of the parabola. So in the fourth problem, if I take m is the slope of the normal, then that will be slope of the tangent to the parabola x square equal minus 12y also. So for the parabola y square equal to 4ax, tangent is of the form y equal to mx plus a by m. And whenever you want to have a equation with respect to the parabola x square equal to 4ay, just interchange x and y. That means x equal to my plus a by m. But here m is not the slope of the tangent. So to have this m is the tangent, m is the slope of the tangent. So replace m with 1 by m. That means x equal to y by m plus am. So the equation of the tangent to the parabola x square equal to 4ay with the slope m is y equal to mx minus am square. So for the parabola x square equal to minus 12y, The value of a is minus 3. So the equation of the tangent is y equal mx plus 3m square. Now, equation of the normal to the parabola y square equal to 4ax is y equal to mx minus 2am minus am cube. But the parabola given is y square equal to 4ax, so a equal to 1. Now, these two equations represent the same. So solve the cubic equation. So the values will be minus 1 and minus 2 and 0. Now, so the slopes of L1 and L2 will be minus 1 and minus 2. So the absolute value is difference is 1. The option C. So the axis of the parabola is x-axis. P is a point on the parabola. The tangent intersect at a point T. If it makes an angle theta, then SP makes an angle 2 theta with x-axis, because focus is equidistant from a point on the tangent point of contact, which is the point where it intersects the axis. That is SP equal to ST. So the angle made by SP with x-axis will be 2 theta. Because the equation of tangent is given. So tan theta equal to 3/4. Then you can calculate the tan 2 theta value. Once you know tan 2 theta, that means you know the slope of SP. So slope of SP you know, and the point you know. So you can write the equation of SP, which intersects the x-axis at S. Then you'll get the coordinates of the focus. Once you get the coordinates of the focus, you can calculate the perpendicular distance. Got anybody value? You should get 2.5. So the sixth problem is PSQ is a focal chord of the parabola y square equal to 8x. If PS equal to 6, then find the square of the slope of the chord PQ. Options are 2 upon root 5, 4/5, 5/4, and 8. 7. Tangents to the parabola y square equal to 8x at P in bracket T1 and Q in bracket T2, where T1 and T2 are parameters, meet at the point capital T. If triangle PTQ is a right angled at T, then 1 upon PS plus 1 upon QS equal to dash. So here PSQ is a focal chord. So P if I take as 80 square comma 280, and SP, SQ and semi-lattice rectum are in harmonic progression. So from that you can get the value of SQ equal to 3, then PQ equal to 9. So the formula for the length of focal chord is A into T plus 1/2 whole square, and slope of the SP is 280 upon A into T square minus 1. So using T plus 1/2 whole square, we can calculate T minus 1/2 whole square, which is 1/2. So square of the slope of the chord is 8. In the next problem, tangents to the parabola y square equal to 4x at P T1 and Q T2 meet at a T. Now, can you conclude anything from this? Where will be T?
Directrix.
Directrix. Once it is on directrix, then what is the relation between T1 and T2? T1, T2 equal to -1. Then PQ becomes what? Focal chord. Once PQ is a focal chord, then 1/SP plus 1/SQ equal to what? This formula you can apply. That is semi-lattice rectum formula. That is 2 upon 2A. That is 1/A. What is A equal to? 2. So 1/2. So the eighth problem is the length of focal chord of the parabola y square equal 4x at a distance of 0.4 units from origin is. Options are 22, 23, 24, and 25. 9. Let points A1, A2, A3 lie on the parabola y square equal to 4x. if triangle A1, A2, A3 is an equilateral triangle and normals at points A1, A2 and A3 on this parabola meet at t, 0, then what is the value of t? First option 24, second 26, third 38, fourth is 28. So in the eighth problem, so if theta is the inclination of the focal chord, then the length of focal chord formula is 4a cosecant square theta. So here the distance OS equal to 0.4 and the value of A is 1. Then you can calculate cosecant theta and then simplify. Then you'll get 25. In the next problem, A1, A2, A3 is an equilateral triangle which is possible only when one of the vertex must coincide with the vertex of the parabola. Then find the slope and then calculate equation of the normal. So one vertex is origin. So slope of A1, A3 is 2 upon T1, which is equal to tan 30, that is 1 by root 3. So the parameter will be 2 root 3. So equation of the normal at A1 intersects the axis at t, 0. So equation substitute in the equation of the normal t, 0, then you will get the value of t as 28. So the 10th problem is the set of points on the axis of parabola y square minus 2y minus 4x plus 5 equal to 0, from which all the three normals drawn to the parabola are real and distinct is the first option. All the ordered pairs x, 1 such that x greater than 3. Second option, x, minus 1 such that x greater than equal to 1. Third option, x, 3 such that x greater than equal to 1. Fourth option, x, minus 3 such that x greater than or equal to 3. So we can convert the equation in a standard form as y minus 1 whole square equal to 4 into x minus 1. So the axis of the parabola is y equal to 1 and the value of a is also 1. So the point on x-axis, axis of the parabola is of the form x, 1. So y coordinate is 1. From this also we can conclude the option A. But if you are trying to derive, so equation of the normal in the slope form is y minus 1 equal to m into x minus 1 minus 2m minus m cube. And the y coordinate is 1 because the normal is passing to the point x, 1. So you will get x equal m square plus 3. So x must be greater than 3 because the normals must be distinct.